Heterogeneous System Architecture. Heterogeneous System Architecture (HSA) is a cross-vendor set of specifications that allow for the integration of central processing units and graphics processors on the same bus with shared memory and tasks. The HSA is being developed by the HSA Foundation, which includes, among many others, AMD and ARM. The platform's stated aim is to reduce communication latency between CPU, GPU, and other compute devices, and make these various devices more compatible from a programmer's perspective, relieving the programmer of the task of planning the moving of data between devices' disjoint memories as must currently be done with OpenCL or CUDA. CUDA and OpenCL, as well as most other fairly advanced programming languages, can use HSA to increase their execution performance. Heterogeneous computing is widely used in system-on-chip devices such as tablets, smartphones, other mobile devices, and video game consoles. HSA allows programs to use the graphics processor for floating-point calculations without separate memory or scheduling. Rationale. The rationale behind HSA is to ease the burden on programmers when offloading calculations to the GPU. Originally driven solely by AMD and called the FSA, the idea was extended to encompass processing units other than GPU, such as other manufacturers' DSP as well. Modern GPU are very well suited to perform single instruction, multiple data SIMD, and single instruction, multiple threads SIMT, while modern CPU are still being optimized for branching, etc. Overview. Originally introduced by embedded systems such as the Cell Broadband Engine, sharing system memory directly between multiple system actors makes heterogeneous computing more mainstream. Heterogeneous computing itself refers to systems that contain multiple processing units, central processing units CPU, graphics processing units GPU, digital signal processors DSP, or any type of application-specific integrated circuits ASICs. The system architecture allows any accelerator, for instance a graphics processor, to operate at the same processing level as the system's CPU. Among its main features, HSA defines a unified virtual address space for compute devices, where GPU traditionally have their own memory, separate from the main CPU memory. HSA requires these devices to share page tables so that devices can exchange data by sharing pointers. This is to be supported by custom memory management units. To render interoperability possible, and also to ease various aspects of programming, HSA is intended to be ISA agnostic for both CPU and accelerators, and to support high-level programming languages. So far, the HSA specifications cover HSA Intermediate Layer, HSAL Heterogeneous System Architecture Intermediate Language, a virtual instruction set for parallel programs, similar to LLVM intermediate representation and SPEAR used by OpenCL and Vulkan, finalized to a specific instruction set by a JIT compiler, make late decisions on which course should run a task, explicitly parallel, supports exceptions, virtual functions, and other high-level features, debugging support. HSA memory model. Compatible with C++11, OpenCL, Java and NET memory models. Relaxed consistency. Designed to support both managed languages, e.g. Java, and unmanaged languages, e.g. C, GC, EGC. Will make it much easier to develop third-party compilers for a wide range of heterogeneous products programmed in Fortran, C++, C++ AMP, Java, et al. HSA dispatcher and runtime. Designed to enable heterogeneous task queuing, a work queue per core, distribution of work into queues, load balancing by work stealing. Any core can schedule work for any other, including itself. Significant reduction of overhead of scheduling work for a core. Mobile devices are one of the HSA application areas in which it yields improved power efficiency. Block diagrams. The illustrations below compare CPU-GPU coordination under HSA versus under traditional architectures. Software support. Some of the HSA-specific features implemented in the hardware need to be supported by the operating system kernel and specific device drivers. For example, support for AMD Radeon and AMD Fire Pro graphics cards and APU based on Graphics Core Next GCN was merged into version 3.19 of the Linux kernel mainline, released on 8 February 2015. Programs do not interact directly with AMD, but queue their jobs utilizing the HSA runtime. This very first implementation, known as AMD, focuses on Kaveri, or Berlin APU, and works alongside the existing Radeon kernel graphics driver. Additionally, AMD supports heterogeneous queuing HQ, which aims to simplify the distribution of computational jobs among multiple CPU and GPU from the programmer's perspective. Support for heterogeneous memory management suited only for graphics hardware featuring version 2 of the AMD IMU, was accepted into the Linux kernel mainline version 4.14. Integrated support for HSA platforms has been announced for the Sumatra release of OpenJDK, due in 2015. AMD APP SDK is AMD proprietary software development kit targeting parallel computing, available for Microsoft Windows and Linux. Bolt is a C++ template library optimized for heterogeneous computing. GPU Open comprehends a couple of other software tools related to HSA. CUDA Excel version 2.0 includes an HSA profiler. Hardware support. AMD. As of February 2015, only AMD Kaveri series APU CF, Kaveri desktop processors and Kaveri mobile processors and Sony's PlayStation 4 allowed the integrated GPU to access memory via version 2 of the AMD IMU. Earlier APU Trinity and Richland included the version 2 IMU functionality, but only for use by an external GPU connected via PCI Express. Postminis 2015 Carrizo and Bristol Ridge APU also include the version 2 IMU functionality for the integrated GPU. The following table shows features of AMD APU. See also list of AMD accelerated processing units. ARM. ARM Bifrost microarchitecture, as implemented in the Mali G71, is fully compliant with the HSA 1.1 hardware specifications. As of June 2016, ARM has not announced software support that would use this hardware feature.